Hi everyone, I'm Yash and today I'm going to present our research on a type of ad fraud called dark pooling. Put simply, in online advertising, ad networks bundle or pool ad inventory, also known as ad slots, of different publisher websites, which can include both good and bad publishers. Due to this dark pooling of good and bad ad inventory, advertisers may inadvertently end up buying ad inventory on a bad publisher. In this paper, for the first time, we study how misinformation websites use dark pooling to deceptively monetize themselves. To understand this, let's use the simple analogy in a supply chain of mangoes. Let's suppose there are two mango farms, A and B. Farmers of these farms sell their produce to a broker who basically bundles these mangoes into crates and further sells them to retailers. We as consumers go and buy mangoes from retailers like Walmart. Now, if some of these mangoes may happen to taste bad, we as a buyer would not be able to tell where these mangoes came from. This is because mangoes from multiple farms were bundled together and then sold from the broker to the retailer. This is an example of pooling in the supply chain of mangoes. Pooling happens in a similar fashion in online advertising supply chain. In online advertising, publishers work with brokers called SSPs or supply-side platforms to sell their ad inventory at ad exchanges. These SSPs send ad requests to the ad exchanges for the inventory on the pool of publishers that they are working with. Similarly, on the buy side, advertisers also work with brokers called DSPs or demand-side platforms to buy the ad inventory at ad exchanges. IAB, or Interactive Advertising Bureau, introduced some transparency standards such as ads.txt and sellers.json to improve the transparency of such pooling in the ad tech supply chain. Ads.txt is hosted at the root domain of a publisher website, and it requires all the publisher websites to list sellers that are authorized to sell the inventory on that publisher. Similarly, sellers.json is hosted at the root domain of an SSP or an ad network, requiring them to list all the publishers whose inventory they are selling. Unfortunately, these standards are not well adopted, and even when they are, there remains a lot of misrepresentations that hinder transparency. So how does an ad from a reputable brand end up on a misinformative website like bad.com due to dark pooling? To precisely understand this, let's look at this scenario by drawing an inspiration from the supply chain of mangoes. Here, bad.com and good.com both work with some sort of an ad syndication network like intermediary.com. Intermediary.com essentially aggregates or pools ad inventory from different publishers that it is working with, providing them an indirect access to the AdX. This is because intermediary already works with the AdX and is assigned some seller ID as 123 in this case. Now, Ad Exchange could end up auctioning a misrepresented or a deceptive inventory from buyer bad.com such that advertisers buying the inventory on the ad exchange might think that they are buying the inventory on good.com, whereas they actually end up buying the inventory on bad.com. This is an example of dark pooling in the supply chain ecosystem. To summarize, pooling refers simply to the sharing of resources by organizationally related entities. For example, two child publishers of the same parent company can share publisher ID or seller ID of their parent to monetize themselves. This kind of pooling is legit and is used to efficiently manage the ad inventory of related publishers. However, dark pooling is wherein publisher IDs are shared by organizationally unrelated publishers to deceptively monetize their ad inventory. In this figure, note that the publishers A and B have the same entry in their ads.txt file, where they're authorizing the account 123 as their direct seller. Now, if the account with ID 123 on adx.com is owned by publisher A, and publisher A and B are organizationally related entities, then this is a genuine case of pooling. However, if they are unrelated, then account 123 on adx.com is being dark pooled. To be more specific, we classify pools as homogeneous and heterogeneous based on their organizational relationship. If two entities have the same parent owner, the pool is classified as homogeneous, else heterogeneous. Further, if we are unable to find any public documentation of a relationship between different entities in a pool, then we consider it as an unauthorized pool. These heterogeneous and unauthorized pools are considered as dark pools in our study. But can pooling be evaded? Advertisers mainly rely on brand safety features to avoid problematic ad inventory. However, brand safety can fail against dark pooling. Let's understand how. A common approach to implement brand safety is to filter or block certain publisher IDs or seller IDs. In this scenario, if the advertiser or DSP blocks all bid requests with publisher ID A1, then it will end up blocking ad inventory of all publishers, including the good ones, which are working with the intermediary ad syndication network. This collateral damage might be unacceptable to an advertiser if they want to serve ads on good publishers in the network of the intermediary. Other brand safety implementations that rely on domain or keyword-based filtering also face similar issues. In this research project, we aim to answer the following three main research questions. First, we investigate the compliance with IAB's ads.txt and sellers.json transparency standards. Second, we study how prevalent is dark pooling on misinformation websites and on the broader web. And finally, we investigate the effectiveness of brand safety services by analyzing the ads from reputable brands that end up on misinformative websites. To answer these research questions, we collect three types of data. We first curate a list of known misinformation and control, that is non-misinformation websites, and crawl their ads.txt files. From these ads.txt files, we extract seller domains that are either intermediary or both and crawl their sellers.json files. This is a static crawl. Second, we load the misinformative websites in a web browser and collect all the network traffic information and identify the advertising traffic using filter lists in the form of shown triplets. Third, we click on ads on the web pages to record the landing page of the click navigation. Next, I'll discuss our results. For the first research question regarding the compliance of ads.txt and sellers.json standards, we analyze various types of misrepresentations on misinformation websites and control websites. This table here lists a few types of ads.txt and sellers.json misrepresentations. Our research paper contains a list of many more misrepresentations. We find that ads.txt misrepresentations are far more common on misinformation websites than on the control websites. The difference is further exacerbated for sellers.json. 54.8% of sellers.json that list misinformation websites include invalid domain names. 46.1% of them also have confidential entries. Such misrepresentations that are far more common on misinformation sites and ad networks that list those misinformation sites hinder the ability of buyers to reliably figure out the source of the ad inventory that they are buying from. Not shown here, but to our disappointment, we found that more than half of the ad network sellers.json files listed at least one misinformation website. The ad network with the highest number of misinformation websites was ref content, with more than 200 misinformation sites in its JSON file. Here are the results of pooling based on our static analysis of ads.txt and sellers.json files. Overall, among top 100K websites, we observed 79K pools, out of which around 11% were dark pools that contained at least one misinformation website. We find that misinformation pools are 2 times more likely to be heterogeneous and 10 times larger in size than the pools that do not include any misinformation sites. The size of average heterogeneous misinformation pools is around 500 websites. Next, we confirm the existence of these misinformation pools detected based on the static analysis of ads.txt and sellers.json files by dynamically loading the misinformation websites in a web browser. We confirmed and obtained around 300 unique misinformation pools. We find that ad networks such as 33across and Gourmet Ads are the owner of the most dark pools containing misinformation websites. One pool by 33across had as many as 30 misinformation sites, while one pool by Gourmet Ads had 23 misinformation websites. The ad exchange that listed most of these dark pools of misinformation websites was Pubmatic. Finally, we analyzed brands whose ads were observed on misinformation websites. We collected a total of 4,200 ads from approximately 2,000 distinct brands on misinformation sites. We narrowly classify a brand to be reputable if its domain is ranked amongst the top 1,000 sites. We observe various examples of prevalent popular brands advertising on these misinformation websites. Overall, we observe a non-trivial number of reputable brands as shown in this figure. But how does pooling impact this? To answer this, we compute the following conditional probabilities. As shown in the figure by the first 2 bars, we find that conditional probability of an ad from a reputable brand to end up on a misinformative website, given that the misinformation site has one or more dark pools, is higher than the misinformation website being part of no dark pools. This means that ads from more reputable brands end up on misinformation sites which are part of more dark pools. Our disclosures to reputable brands revealed that they did not want to advertise on misinformation websites and that they were typically unaware that their advertising dollars were used to buy dark pooled ad inventory on these misinformation sites. In summary, first, we found that misrepresentations are prevalent across misinformation websites, suggesting poor compliance with the IAB's transparency standards. Second, we found a large number of dark pools on misinformation websites. And finally, we found that ads from reputable brands frequently end up on misinformation sites that are more frequently engaging in dark pooling. To conclude, our research highlights that there is a need for better compliance with the existing standards, such as ads.txt and sellers.json, and that there is also a need for better standards to prevent such fraud from the edtech supply chain. Second, through our disclosures, we observe that although the brands fund the edtech supply chain, they are the entities who are not in control of where their ads appear. Dark pooling spans across multiple stakeholders, and there is a need to develop effective disclosures or notification mechanisms to mitigate this problem. Finally, on the regulatory side, the Digital Services or DSA Act has already went into effect in the EU. It imposes requirements on large online platforms to assess whether and how their advertising systems are manipulated. D'Souza in the US aims to have similar transparency requirements. We believe that ad transparency requirements geared towards ad networks and ad exchanges can help mitigate this problem. Thank you for listening. If you want more details, I would encourage you to read our research paper or reach out to me.